Hello, everyone. It looks like some people are still joining. I'm going to give it one more minute and then we'll start promptly at 12:01. All right. Good afternoon, everyone, and thank you for joining us. This is Sarah Davison with Viavi Marketing. I want to thank you all for joining our call today on the basics of digital radio testing and the importance of measurement technique. We have a lot to share with you, but before we begin, this webinar is going to be recorded and will be available for you to review or share with your teams in approximately 24 hours. We will send an email to all attendees with a link with the recorded version. All lines are on mute, but we will be monitoring the chat and will answer your questions at the end of the webinar or reach out to you individually to ensure you get the answers you seek. And now I'd like to turn it over to our speaker today, Dave Hansen.
Thank you, Sarah. Welcome everybody to today's presentation. Hopefully it's shaping up to be a beautiful Friday where you are. I do want to point out, obviously we're going to talk about digital radio testing. That is the point of today's webinar. But I guess to set the expectation, we're not in an hour's time going to really get into the nuts and bolts of how digital radios work or how digital radio modulation occurs or anything quite that deep. Okay, so we're going to talk kind of on the surface about digital radios. The proper way to test them, the proper meters to use, and that sort of thing. So I just want to make sure everybody understands that. That said, we're happy to discuss those types of things with you at the end of this webinar or anytime afterward. If you do have additional questions, additional things you'd like to learn about, please reach out to us either directly or through our sales team, and we'll be happy to answer any questions that you have. So we are going to focus on digital radios and specifically on how digital radios, the testing of them differs from analog radios and some of the errors that are commonly made. I am Dave Hansen. I'm the guy up in the upper left corner of your screen right now. Also online with us, not speaking, I guess, but online, and they'll be taking part in the Q&A at the end of this. Bill Nichols and Mike Fortna, a couple of our other field applications engineers. I guess as things go, I'm the youngster in the group. I've been with the company for 21 years now. Started at IFR, as did Bill and Mike, and I guess combined with Don Graham as well, we have almost 140 years of total experience. So again, I'm only 20 years of that, so you can kind of do the math on how much experience the other guys have. I don't want to call them old, but anyway, again, we encourage you to jot down our email addresses there, or like I said, call through our sales department and ask any questions you have that we're not able to get to at the end of today's webinar. A little bit about who we are. Viavi was formed out of the former JDSU or JDS Uniphase back in 2015. Our team here in Wichita, Kansas is made up of people that have been here for decades, and same people, same place, same company, same processes and all that. So what that means is that I guess we're here for the long run, and should you need support, technical support, questions answered, that sort of thing, we are here for you. Our product focus here in Wichita is, of course, the radio test sets, the 3920B, the 8800SX, and the 3550R. Those are our three, with the 3920 being kind of the flagship of those three. 8800SX, kind of the new kid on the block, and has been well received for what it does. I guess I'll also mention there that Viavi does have, we do have our hands in a lot of other technologies as well. Just some kind of fun facts there at the bottom. Once again, you can kind of see here that Viavi itself has been around for quite a while, going back in one form or another back to about 1923 there. And of course, through those years, the company has evolved and changed. Now that IFR or slash Aeroflex is part of the Viavi team. From our perspective, it's been a wonderful thing because as you're well aware, our industry is changing. And we are all being exposed to a lot of new technologies or new to us technologies. A lot of us are starting to work with fiber in our sites now. I deal with quite a few customers now who are maintaining the fiber just as they do the RF and all the copper stuff. So you know, being able to go to one place to get all of your communications test gear, whether it's RF or fiber or network or what have you, is a pretty neat deal for us. And again, we're still in the process of learning some of these other technologies, as I'm sure some of you are. And it's so far it's been a fun journey. So today we're going to talk about, again, digital radios and with a focus on, I guess, comparing them in some ways to analog radios and how that testing occurs. The things that can go wrong, the things that you can do that that help the radio, and the things you can do that don't help the radio. So I guess we'll lump that into vulnerabilities of analog alignment. And bear in mind, you know, your digital radios, even though we're talking about a digital modulation, at the heart of that radio, at least for today, I'm sure one of these days this is going to start to change, but at least as of today, when we look at our digital radios, there's still an analog radio at the heart of that. So an analog RF device at the heart of it that's generating that RF. So those analog alignments are a lot more critical now, and we'll talk about that. Also, we're going to talk about the benefits of our Autotest environment. We've got Autotest for the 8800SX and Autotest 2 for the 3920B. Both of those, well, it's the same process, but obviously different platforms. It takes the testing of your radios and the alignment of your radios and automates it for you, and we'll talk about why that's a good thing. The last thing we'll talk about is the ability to control the equipment, to control the test set through a remote connection, through a network connection there. So we'll talk about specifically how to do that through VNC. If you're not familiar with VNC, we'll talk a little bit more about it here when we get to that point. Once again, probably not going to get into the nuts and bolts of how VNC works. That's a little deeper than we need to go. But know that we can control the equipment through this VNC connection, and there's some benefits to that as well. So digital radios, signals, digital radios in general, there's a lot of different protocols out there. The three that we're going to focus on today, and not so much, I guess maybe I shouldn't say we're going to focus on them, but the three that what we're going to talk about today applies to most is going to be P25 DMR and NXDN. P25 came about back in the early 2000s. After 9/11, there was it became apparent that interoperability was something we needed to focus on, and there's not, well, prior to that, there wasn't a common system that everybody was on, and so you had situations where first responders could not talk to other first responders, and because of that, you know, like I said, it became apparent that we needed to come up with a way to connect all of these different organizations. So P25 came about, and as such was kind of developed as a public safety system. So that was its primary focus, and still today, because of the cost of P25 equipment, that tends to be the place you find P25 used the most. After P25 really, I guess, became big, DMR and NXDN were also developed, and competing technologies, if you will, but both were developed with commercial customers in mind. So taking that digital technology, the digital things that we learned with P25 and applying them to slightly different protocols in a way that it could replace your older analog systems at a lower cost for the customer. That said, one of the things we've found recently is that as organizations are looking to save money, stay within budgets and that sort of thing, a lot of public safety organizations are also starting to use DMR and NXDN in their communications. And they may not be their primary means of communication, but they are using these radios and they're finding ways to interface them with their P25 system. So I say all that to say this. When we're testing our digital radios, whether we're testing P25, DMR, NXDN, whether it's public safety or commercial application, it's important that we issue the best radio that we can. So if you're dealing with public safety, that means that you're issuing a radio to somebody whose life may depend on their ability to use that radio. If that radio is not functioning as well as it can, then you have a situation where somebody could lose their life or other things could happen that are, bad. So, in that situation, obviously it's imperative that the radio you issue works and works right. If you are dealing with commercial customers, we may not be talking about life and death situations, but from that customer's perspective, that radio may be the lifeblood of their business. So if that construction company, if the boss can't talk to his drivers, he's losing money because now he's got drivers out there that he can't communicate with. So even if it's not a life and death situation, it's still of utmost importance to that customer that his radios work right. And if it doesn't work right, it comes back to the person that maintained it, right? And that's going to be us. So we want to make sure that all these radios, whether they're public safety or commercial or whatever, are working as well as they can. So let's talk a little bit about analog and digital measurements. Of course, most of us grew up in the analog world. Well, I guess we're getting into this day and age now where a lot of people are not familiar with analog, but I would say still that most of us grew up in the analog world and we're familiar with things that we would test with an analog radio: frequency, modulation, power, sensitivity, those types of things. And the neat thing with digital is that we don't have to learn a whole new playbook. We're still going to be testing frequency and modulation and power and sensitivity, but we're going to be doing so in a slightly different manner. So if we look at the things we're going to measure, again, RF frequency, one of the first things we look at is the reference oscillator in this radio and make sure that it's on frequency. RF frequency is one of the key components of a working radio. And when we talk about digital radios, there's a couple of parameters that have a profound effect on the effectivity of that radio. So if you are off frequency with a digital radio, the effect is going to be more pronounced than it is with analog. So a lot of these measurements, even though they're similar, when we start talking about digital radios, they make a much larger difference in the way that the radio performs. And again, RF frequency is one of those. Transmit power is another one. Transmit power, not as critical, but it's still something we need to measure. We still have to make adjustments for transmitted power. Modulation, with an analog radio, we're typically in the past looking at either AM or FM. And today with our digital radios, we're still looking at a form of FM frequency modulation. But now we're looking at what we call symbol deviation. So instead of just this broad modulation that's occurring, we have very specific amounts of deviation that are required for the receiver to be able to decode that signal. If our symbol deviation is incorrect, our receiver is not going to be able to pick up that signal. As digital radios came into being, one of the things that we heard a lot from customers was that digital radios just weren't as good as analog. And a lot of that stemmed from the fact that with an analog radio, you could get away with a lot of misadjustment and the radio would still function fairly well. With digital radios, that's not necessarily the case. Now, if you have a digital radio and an analog radio that are both aligned properly, you are going to see a better quality of signal with a digital signal than you will with analog. So if you, once again, if we look at an apples to apples, I guess, comparison there, for the same alignment of the same proper alignment of a radio, analog versus digital, the digital is going to outperform the analog radio in terms of signal quality. Again, if you have a poorly aligned digital radio, that's not necessarily true, and it may look like the digital radio performs worse. So digital radio, the alignment is critical. Again, frequency and symbol deviation are the two biggest things that affect that. And if those are not aligned properly and measured properly, you run the risk of having a degraded performance. Receive sensitivity is another one of those alignments, or not alignments, but tests that we do with the analog radio. We would do a SINAD measurement or a signal to noise measurement. And in digital, we can't do that same type of measurement. So you'll see here, you start to see that we have measurements that we cannot do with an analog meter. And received bit error rate is one of those. Fortunately for us, received bit error rate doesn't require any specific meter, but we do have to have the ability in our service monitor to transmit a specific test pattern to the radio so that it can measure its received bit error rate. If we are not able with our service monitor to generate that transmitted pattern, that test pattern, there's no way for that radio to determine whether it has good sensitivity or not. So once again, there's a difference between how we're measuring this. But it is still a measure of the same quality, in this case, received sensitivity. And then we look at a couple of other, or 4 other different measurements that we are concerned with the digital radio, that there is no analog equivalent. So there is no equivalent meter in an analog service monitor for modulation fidelity or FSK error. That's a measure of the quality of the signal. And again, we're talking about a digital signal, so it takes a special meter to be able to calculate how good that signal is. If we don't have that meter, we don't have a way of knowing how good that signal is that we're broadcasting, that we're transmitting from our radio. Once again, if we don't know how good our radio is, we may be issuing a radio that's maybe not as good as it should be. And if that's the case, then we put the customer in a bad spot of not being able to communicate with their people. Symbol clock error is another one of those measurements that we need to be able to measure. We need to be able to look at to make sure it's good. If it's not, once again, we cause a loss of performance in that radio. Slot power and magnitude error. Now, those two are not specifically related to digital measurements, but TDMA signals rather used in DMR and P25 phase 2 do have as a 2-slot TDMA, so they do have on times and off times, and if we're not able to properly measure the power in the right slot at the right time, we're not going to be able to properly characterize those radios. So once again, even though those aren't specific to digital radios, they are specific to the digital modulations that we're talking about. So we'll start looking at some of these those measurements I just mentioned. We'll start looking at how those are impacted or how we can measure them on the service monitor. And you can see I've got my 8800SX screen up here at the moment, and that's kind of what we're going to use as our basis for the most of these points. Here we're talking about frequency error. So I mentioned earlier the frequency error is one of those critical measurements, critical parameters that have to be right in order for our digital radios to communicate. If they're off frequency, they just aren't going to work as well. So when we look at a digital signal, you have to realize that these digital signals are not like typical FM signals where the modulation is fairly symmetrical. So if we looked at an FM signal, we would see, especially if we looked at an envelope, you'd see that the modulation is fairly symmetrical above and below the carrier. With digital modulation, that's not necessarily the case. The pattern of ones and zeros that we're transmitting could be in any order. And that combination, or that pattern, if you will, of ones and zeros may cause the frequency to be skewed to one side or the other. What we see on the screen right now is a standard 1011, what we call a standard 1011 pattern used for testing P25 radios. And you can see in this distribution plot here on the lower right corner, the plus 600 hertz symbol is used far more than the other three. In fact, it's almost used as much as the other three combined. What that means is we're spending a lot more time, that RF signal spending a lot more time above the carrier frequency than it is at or below the carrier frequency. If we use an analog frequency counter to measure that, because it's not symmetrical, because it spends more time above the carrier frequency, it's going to cause that frequency counter to also reflect an error above the carrier frequency. That's obviously not what we want happening. We want to actually know what the real center frequency is, what the real RF frequency is. And so it's imperative that we use a proper frequency error meter for these digital signals. Here we have a couple screenshots of the same signal, standard 1011 pattern. And you can see on the left side, again, same frequency, same signal. On the left side, we have an analog meter measuring 150 hertz, which is very typical of this standard 1011 pattern, even though that is perfectly on frequency. If we look at the right side, using the proper meter, we can actually see that the frequency error is almost zero. Now, I've talked to customers over the years who have tested their digital radios with an analog service monitor, and they've told me, hey, my radio is off frequency, but if I adjust it so that it's on frequency, in other words, they key the radio up and it's transmitting this pattern, and they've adjusted it so that the analog frequency counter reads zero. Now the radio is actually off frequency, and what they'll report is the radio performance suffers. In other words, they get out into the field and they lose range, or they lose communication in buildings and things like that. Whereas if we are able to use the digital frequency error meter, we can properly align that reference oscillator, and we don't lose that performance. So again, real world scenario there. Customers use the incorrect meter to align this, and it hurts the performance of the radio. Symbol deviation is another one of those, is the other critical measurement, I guess, of the of a digital radio. So we're in an analog radio, we would have, say, FM deviation. Here we're looking at what we call symbol deviation. And what that means is that digital radio, the receiver is looking for that signal to be at a specific amount of deviation at symbol time. So when it samples it, it expects it to be at one of 4 different places. If it's not at one of those 4 different places, it doesn't know what to do with it. Is that a 1 or is it a 0? It's not sure. So this the importance of that is that if you are not using a digital service monitor that is capable of measuring your digital radios, there is no way to be sure that your symbol deviation is correct. So here, once again, transmitting a standard 1011 pattern P25 signal into this analog configured 8800, you can see the modulation meter is reading 3.2 kilohertz. Now, I'm going to use, in this case, P25 as my example. What symbol deviation should be 1800 hertz. Obviously, that's not 1800 hertz. If we were able to look at that on the oscope, it would look something like, well, there's 1800 hertz in the red lines there. So you can see that on the oscope that the symbol deviation does not correlate to the FM deviation that is measured using a standard modulation meter. So that means that you can't use that modulation meter to measure your symbol deviation. And another thing to keep in mind is that there's not really a direct correlation between those two. So if I have a good radio and I key it up and I measure 3.2 kilohertz of deviation, I can't be assured that the next radio I pick up, if it has 3.2 kilohertz of deviation, that my symbol deviation is going to be the same. And that could differ from radio to radio, from model to model, manufacturer to manufacturer. There's just no way to correlate those two in a reliable way to know that the radio you're testing is actually good. So again, you can see here that we're going to display an incorrect value. Now, if we were to display this on a digital meter, and here you see our symbol deviation meter, and I've got some limit lines set here so you can see the color coding. You can see it's green, telling us that this is good. 1800 hertz, within 10% of that is good, and we have a way of actually measuring that. And with the digital plots on the right, you can visually see that symbol deviation is what it's supposed to be. Once again, there's no analog equivalent to that, so you have to use the right meter for doing this. Symbol deviation, you can also, again, on the eye diagram, at symbol time, which is the vertical line there in the middle, you can kind of see that those crossing points are occurring where they're supposed to. Now, we could, and I'll talk a little bit about the symbol clock error here in a moment, but excuse me. If we had any symbol clock error, we would be able to see that on that eye diagram as well. And again, this is just one of those things that you can look at on a digital plot like this that you cannot visualize in any way on an analog device. Here's just kind of a couple of examples of symbol deviation failures where we're actually outside the limits, and again, you can see there the meters red and blue telling us that those are failing measurements. On the eye diagram, of course, you can see that the symbol deviation on the left is well outside the 1800 hertz, and on the right is well below. The thing to note about this is that this radio, and this was a misaligned XTS 5000 that we were testing. This radio probably would actually talk on the system if you were standing in the shop just down the street from the tower. And this is a common occurrence. So I get to talking to a customer, and they'll say, well, we tested the radio by keying it up, and as long as it gets on the system, we know it's good. But the problem with that philosophy is that if you are testing your radio simply by keying it up and verifying it gets on the system, all you're really getting is a snapshot of that radio's performance at that location. And the area where radio performance is going to be tested the most in the real world is going to be at the fringes of the radio's range. So the methodology there, by testing the radio in the shop just down the street from the tower, it provides a false sense of security, because you've tested the radio, keyed it up, and it got on the system, and you said, yes, it works. But now you've got a user of that radio who isn't necessarily hanging around that tower. They may be driving out to the far corners of the county where there's not very good coverage. And if you get out into some of these areas where there's not very good coverage, if your radio performs worse than it should, you may be expecting to get a signal there, and in fact you don't. So again, going back to that real life scenario of first responder relying on that radio to be able to communicate with dispatch, they get out into the sticks, and now they cannot communicate with dispatch because that radio wasn't tested in a proper way. So being able to verify that the symbol deviation is good and that it is truly within spec is imperative. So I mentioned symbol clock error there when we were talking about the symbol deviation. Again, there is no analog meter for measuring this, and there's no way to know with an analog service monitor whether your symbol clock error is acceptable or not. So here we have the symbol clock error meter in the lower left corner. On the right side of the screen, of course, is the eye diagram once again. The eye diagram is a very versatile tool for visualizing what that signal is doing. So once again, here we can actually verify that those crossings are occurring at the middle, at the center of that plot. If it was not occurring at the center of the plot, if it was skewed to the left or the right, that additional symbol clock error is going to cause high bit error rate. And the thing with the symbol clock error measurement, if you have excessive symbol clock error, if you can't diagnose it properly, you can spend a lot of time running around in circles trying to figure out why do you have high bit error rate, when in fact it's just because of the symbol clock error. It could look like a lot of other things in other words. So you could look at this and say, well, we've got high modulation fidelity, Why is that? Is it because our frequency is off? Well, no, our frequency is good. Is it because our symbol deviation is off? No, symbol deviation is good. But if that symbol clock error is off, it could look like any of those other things. Once again, one of those things that we need to be able to measure, and the service monitor, a digital radio test set, will allow that. These are just a couple of other digital plots that the 8800 has and the 3920 has that are kind of useful. Again, the eye diagram in the lower right corner, and then a constellation, which kind of gives you a, if you think of that the eye diagram, looking at it from the right, you can kind of see where the deviation is, where that signal is relative to the ideal symbol deviation. So those circles don't necessarily represent specific tolerance or anything like that, but they kind of give you an idea if it's very spread out or if it's wide or narrow. The distribution plot, as much as that looks like a spectral display, it's not. It actually is. It's closer to, I guess, a counter. So we're tallying how frequently each of those symbols is used. And again, this is a P25 signal, so we have 1800 hertz up there for our symbol deviation. So just something that you can use to visualize what that signal is doing. And a lot of times, you look at a number and it tells you some piece of data, but it doesn't give you the whole picture. A lot of times you can look at these graphical displays and get a better idea what is being measured there and how. So transmitted power is something we kind of take for granted as far as being able to measure it. Transmitted power seems like a simple thing. You key your radio up, you look at the power meter, and you get a number. With DMR, and I guess like I said before, P25 Phase 2 is also used as a 2-slot TDMA architecture. So with those types of signals, where the signal is present for one slot and not for the other, if you're using a standard power meter, you're not going to be able to necessarily compensate for that off time. So using the proper power meter, in this case our signal power meter, allows us to look at that transmitted power while that signal is present and ignore it when it's not. Or in this case, we can actually measure the high power and the low power. So we can measure the time slot where it's transmitting, and we can measure to make sure that the power is acceptably low during the off time. Okay, so again, this is one of those things that you need to be able to measure correctly in order to properly align and test your radios. Another TDMA parameter is magnitude error. So the burst that occurs, so each of those bursts that occur in a TDMA signal needs to be of constant amplitude. So in other words, we don't want the power tailing off at the end. We also don't want there to be any ringing on it. The power fluctuates up and down. We want to make sure that the ramps are good so that the power comes up sharply like it should and rolls off sharply like it should. We've seen situations where we're able to diagnose problems with a battery where the ramp up time on one of these bursts had a little, kind of like a little stair step in it. And without being able to look at this on a display like this, like the power profile on the right, you don't have a way of knowing why it's failing if it fails. And if you don't have that magnitude error meter, you don't have a way of knowing if it's even failing. So again, this is one of those things that can affect performance of the radio, but if you don't have a way of measuring it, you don't have a way of knowing for sure whether that radio is as good as it can be. So I've talked about digital radios, and of course, in order to test digital radios, you need to have a test set that's capable of that, and that means using a digital radio test set. And I'm using the 8800 as my example. There are benefits. Even I know a lot of us are still testing analog radios, and even if you're not testing digital radios, there are still benefits to using a modern piece of equipment. I'm pretty old school. I like buttons and switches, but being able to, in this case, configure the screen for the testing that I want to do, in this day and age, of course, a lot of places you've got, say, 10 technicians, but only have budget for 5 service monitors. So that means you have technicians sharing equipment. When that happens, it's nice to be able to configure the equipment for each of those technicians in a way that that technician finds most useful. So if we have a technician that likes to have his generator on his left and his receiver on his right, they can do that. If we have a technician that wants to have them stacked above one another, they can do that. And once that's set up, we can save those configurations, which is something you can't do with a bunch of buttons and switches. So you save that configuration. When that next user comes along, he pulls up his configuration and is ready to go. Same thing can be done for different customers. So if you have different customers that are testing different their radios to different powers, we can set pass-fail limits on a service monitor like this, where if it's above a certain level or between this low and high tolerance, then it passes, and if it's outside of that, it fails. And you can adjust those tolerances or those parameters per customer, and again, save those configurations so you don't have to keep track of what each customer wants. It'll be there already. Being able to configure the unit for each of those situations quickly is a lot of times it's a time saver, but it also can eliminate errors in measurement, because if you can't remember which parameter you're supposed to, or which spec you're supposed to be testing to for this particular customer, then we want to eliminate that. So again, use this type of configuration, or the ability to configure the service monitor, is not just a digital thing. That's something that can be used for analog measurements, for duplexers, for whatever testing you're doing. Another thing that's kind of nice with a digital radio test set is the ability to save things like frequency lists. So if you're testing radios at a list of frequencies, to manually put in each of those frequencies each time you change frequencies is kind of a it's kind of a hassle, I guess is what I would call it. So if you have a list that you can work from, where you just simply tap next and it goes to the next frequency for you, again, kind of a time saver. And that's one of the things that we want to take advantage of. Frequency find is kind of handy as well. So if you don't know, someone brings you a radio and you don't know anything about it, without having to hook that radio up to the computer to read it, you can actually key the radio and find that frequency automatically without having to do a lot of legwork. Again, benefits of having a digital set versus an older analog test set. So let's talk a little bit about auto test. We talked about how to make the most of our measurements. Use the proper meters. Use the I mentioned the pass-fail criteria that we can set in there, and using those meters to make measurements properly, make measurements accurately. Auto test kind of takes that one step further and automates the process. So one of the neat things about auto test is that we get the blessing of each OEM for these scripts that we write and put into the test set. So in other words, we're not just guessing at how this radio is supposed to be aligned. In fact, a lot of the OEMs are using our auto test applications for their testing. I mentioned the proper testing and the proper measurement of our radios. One of the things that goes along with that is consistency. And if you have 3 different technicians testing radios, I can almost assure you that you have 3 different alignments occurring. And Bob at the left may say, well, I'm old school, and I think that putting a little more deviation in makes the radio perform a little bit better. And Tim in the middle says, well, I think that I want to preserve battery life, so I'm going to align the power a little bit on the low side. And Josh on the right says, well, I want to make sure my customer has the best range possible, so I'm going to crank that power all the way up. And what you end up with is this hodgepodge of different alignments of radios out in the field. And remember, I mentioned earlier that the frequency and deviation are critical to that digital radio's performance. Well, if you have a bunch of different radios out in the field that are all aligned with a little bit different deviation, you're not getting the best range out of those. And so in those situations where someone's out at the corner of the county or is in the basement of that hospital, they may not be able to get a signal where they should be able to. Autotest is going to take that human factor out of the process. Okay, it's going to give you consistent alignments, consistent measurements every time. Everything's black and white, either passes or it doesn't. It's either in spec or it isn't, and we're going to align it the same way every time. Another cool thing about Autotest is that because it's automated, because the person running the radio does not have to be an expert technician to test or align that radio, it allows your more skilled, more experienced technicians to go out and do more complex troubleshooting or do site analysis and things of that nature, where you need that experience, where that experience pays off and really is of more benefit. That means that in these situations that we see nowadays, where we have customers who are working in departments that aren't just radio departments. You go to places now and you walk into the radio shop, and it's not just a radio shop anymore. Now it's also the network department, and it's the communications in general department, if you will. So you've got RF guys in there, you've got fiber guys in there, you've got networking guys, and everybody's kind of expected to do everything. One of the classes I taught here a while back was for a customer who had just gone through that process and said, okay, everything is going to be handled by what was then their IT department, and at the time, Autotest wasn't a thing. And when we started talking about radios, all their eyes glazed over, and we weren't able to get very far. So, being able to use Autotest means that you don't have to have people who have 50 years of experience testing radios. Now, somebody can hook the radio up, press the run button, and the service monitor is going to do all the hard work for you. Along with the critical nature of some of our communications now is the necessity to be able to prove the work that was done. And again, whether you're talking public safety or just critical customers, who demand the best performance out of the radios they can get, Autotest is going to store that test data in a text file on the service monitor. Okay, so each time you hit run, we're going to store a unique test file on the unit that's going to show how that radio performed, whether it passed or failed. And should the day come that you have to be able to prove that you tested that radio and that it worked the way you say it worked, the documentation is already there. It's in the unit already. All you have to do is pull that data up, print it off, and provide it to your customer. And there's your proof that you did test the radio, that it did work when you handed it to them, that everything is, or at least was, what it should have been. That happens automatically. You don't have to think about it. Again, happens as soon as we run that radio. Autotest provides quicker test times in most cases. And I've talked to customers over the years who will tell me that they don't need Autotest because they can test their radios faster than any service monitor can. And when we talk about that, what we find is that we're not doing an apples to apples comparison. When I say that I can test and align this radio, the radio that we have hooked up right now is going to take about 10.5 minutes to go through a complete alignment, complete test. And when we talk to customers who say they can test that radio themselves in less time, what we find is that they're not talking about doing a full alignment. We're talking about doing a spot check, a couple frequencies maybe, test transmit power and frequency error, whistle into it, make sure deviation looks like it should look. That's all they're doing. And if you look at the alignment of one of these radios, the manual alignment of one of these radios, where it may take 45 minutes or an hour to manually do that, if I have an 8800 that I can hook my radio up to, and it's going to test and align that radio from start to finish in less than, 10.5, so less than 11 minutes, I can, in an hour, do almost 6 radios through Autotest, where to manually test and align that radio, I was going to get through 1. So just in the test time alone, we're going to be more productive using Autotest than we would if we were manually aligning that radio. The next thing that comes with that the higher productivity also is in the fact that when we're using auto test, we don't have to sit there and babysit the radio. If I'm manually tuning a radio, I have to be physically in front of that radio. I have to be in front of that computer, moving those soft pots back and forth, making measurements, changing frequencies, et cetera, et cetera. And that whole time I'm doing that, that's the only thing I'm doing. If something comes up and I have to go answer the phone, or I have to go to the front counter to help a customer, something like that occurs, that just makes that alignment take that much longer, right? And of course, the longer it takes, the fewer radios you can get through in a day, and the less you get done in that day. With auto test, I don't have to sit here in front of the radio while it tests it. Now, you did see there for a moment, I did have to move a cable from one port to another. Some instances we have to do that, but you're still talking about 15 or 20 seconds to move a cable versus having to sit here in front of that radio the whole day. I've got customers who will have basically like a little assembly line set up where they'll have a patrol car come in. They'll take the mobile radio out of the vehicle, hook it up to the service monitor, hit run. They'll go get the portable radio, update its firmware, maybe reprogram it, do whatever else they need to do with that. And then by the time they get done with that, the mobile's done being auto tested. They can swap the radios. Now they can update the firmware in the mobile and reprogram it and go install it. And by the time everything's done, they've been busy the whole time, but everything kept moving, and they didn't have to. They were able to accomplish more than one task in that amount of time. So while the radio's testing, you can do those things. You can go install a light bar if you need to. You can do any number of other things that that need to be done while auto test is doing its thing. So here's a set of results that this isn't from the radio I'm testing at the moment, of course, but this is a set of results that we stored off of a unit, I guess a few days ago. And you can see that, when I talked about that, being able to prove your work, here in the results file, we have the information about the radio and the service monitor. So you can see on the left side of the screen, we've got the radio's model and serial number. We've got the firmware versions, et cetera, the band of that radio. We've also got the serial number and firmware versions in the service monitor itself that's being used to test it. So there's some traceability that goes along with that. On the right side of the screen, we have a summary of that test, of that radio. So everything that passed, everything that failed. And in fact, you can see here, there is a transmit high power failure. So we could actually go back into these results and look at those results, analyze them, and probably, or maybe anyway, figure out why it failed. Now, it could be that the radio is just faulty, but I've had situations where we can take these results and look at them and figure out exactly why it failed. I had a customer that sent half a dozen radios back to depot because they were failing transmit power. And when he got them back from depot, he retested them, they still failed transmit power. When we looked at the results file, we could see that sure enough, the power was low and we were trying to raise the power. But as we kept trying to raise the power, the transmit power kept dropping. Based on that information, I asked the customer if he was using a battery instead of a battery eliminator, and sure enough, he was. Turns out the battery he was using was several years old and just didn't have the oomph to be able to support being keyed up for more than a couple of seconds. And so, in that case, if we would have been able to look at those results beforehand, he could have saved himself the cost and time of sending those radios to depot, because we could have done that diagnosis through the results themselves. So this provides, again, that traceability and proof of that the radio was tested, and et cetera. But it also gives us the ability to go in and do some diagnostics. Control. Last thing we're going to talk about is controlling the unit remotely. The 8800 is a touchscreen box, and as such, we have the ability to use the touchscreen, and this is the primary means of controlling it, really. The 3920, of course, does have buttons and switches, But for the 8800, being able to, with it being a field box, it's nice to be able to pick it up and hold it in your hand and be able to touch the screen, point right to what you want to change. So if you want to change the frequency, you have direct access to that frequency field, and you can put that information in. Most of our service monitors that you use today are going to be, they're going to have a computer running inside of them. And so we do have the ability, of course, to use a keyboard and mouse as well. Some people prefer that. Some people like to be able to use a mouse to click on a field instead of having to touch the screen or use the buttons on the front panel. Keyboard's real nice if you're saving screenshots and configurations and you want to be able to give those files unique names. So that's kind of handy as well. But if you're in a situation where maybe you can't be in front of that test set, this could be something where maybe you're trying to diagnose some interference that's occurring at a site. Maybe you have a network connection to that area where you can go back to the shop and monitor for that. Being able to remote into that set and actually see what's happening in real time can be a huge benefit, a huge time saver. Save you from driving out 3 hours to a site just to find that whatever interference was there is no longer there. So being able to, let's say, put a test set at a site, put it on the network, go back to the shop, and when that call comes in that there's interference, being able to log into that service monitor and monitor it in real time. You may not be able to fix the problem or diagnose it remotely, but you may be able to get a little more information out of it and figure out what it is you should be looking for when you get out there. So we have that ability through VNC. VNC gives you basically the same control that you would have in front of the unit without having to be in front of it. About the only thing you can't do would be to maybe hook up cables, right? I mean, I haven't found a way to hook up cables from 300 miles away, but pushing buttons and that sort of thing is all just like you were in front of the unit, which is very handy. One thing we did find recently is that, of course, VNC itself is not a secure encrypted means of transmitting data. So what that means is if you do put your service monitor on the network and VNC into it through one of the programs that we use, then you're not necessarily, it's not encrypted in any way. It's open to anybody who's sniffing. And we found that we can actually connect securely and .govs and .mils like this. We can connect securely to that service monitor through an SSH tunnel or secure shell tunnel. So we can connect, very easily without that. But even if we have to have a secure means of remoting into it, we do have the ability to do that. The program that we use most of the time for VNC connecting is called Tight VNC. There's other VNC clients or viewers out there as well. This just happens to be the one that we have found everybody likes and works very well. Again, there's many reasons for doing this. I like it for webinars. I can remote my display to my computer and show it off to other people. I've got customers that do this in the shop even. They'll have a 32-inch monitor on their computer and they can remote the display to their computer, and now they've got a 32-inch display for their 8800 so they can see across the room what's happening without having to walk back across the room to look at it. So handy for that, handy for collaborative efforts. So if you've got a radio that's failing and you would like to get another technician's input on why it's failing, they can remote into your 8800 and see what you're seeing in real time without you having to walk over to them or take a picture and email it to them or whatever. So again, real handy for that. So I know we're getting close to our hour time. If you have, again, here you see a bunch of analog test sets or older test sets. We are happy to work with you if you have trade-ins, if you have older sets that you'd like to upgrade to modern, current day digital radio test sets to test your P25 or your DMR or NXDN radios. Again, we're happy to work with you on that, and just contact our sales department. Like I said before, if you have technical questions about anything we've talked about today, please reach out to one of us applications engineers or to our sales department and say, hey, I've got a technical question. They're going to put you in touch with someone who can answer your questions, and we can go into a lot more detail on a one-on-one basis with you, specifically about your applications instead of this general digital radios overview. So thank you for joining. Bill Nichols and Mike Fortin are online with us, and I know they've been monitoring the questions that people have submitted. And so I think Bill's going to go through those, and we'll take a look at answering as many of those as we can here in the next few minutes. Bill?
Good afternoon. Great job, Dave. I learned a little bit myself today. We had a lot of attendees on here, and glad you all are hanging in there. We have a lot of good questions here too. So we're going to kind of hand off. Mike Fortin is also on here, and he's going to answer some of these questions too. And I'm just going to start off with Scott Hamilton's question about power. And he was asking if you have the mobile in the vehicle and you have the radio connected to a stable power supply, can you connect the service monitor as on a bench and still test the radio in the vehicle? And the answer is yes, with a couple of caveats there. I know folks that'll actually run the 3920s out to the bay, or 8800 for that matter, and they'll use 10 feet of cable to test those mobiles in the vehicle. And as long as you compensate for that loss in that cable, there's no reason you can't test those radios in the vehicle. The other thing, you said stable power supply, and that's a very good point. If you were trying to test the radio with the engine running, the alternator's gonna be charging that battery and probably putting about, it's probably about 14 volts on that. And these radios need to be aligned. Let's take the manufacturer specific. They have particular voltage settings that they need to be set to align the radios. Let's take 13.8 as an example. That's the voltage that you need to align that radio to. And if you've got a high power radio, you need to have a good current limit on that power supply too. 20 amps minimum for a 50 watt, and you'd want even more than that headroom for 100 watt radios, 40 amp. So 20 amp would be fine for up to your 50 watts, and then a 40 amp for 100. So good current limiting on the power supply, and send them to the manufacturer's specific voltage that they're supposed to be aligned at, because it does make a difference swaying that voltage back and forth. So stable power supply, yes, good current limit on the power supply, and have your cable loss compensated for, and you'll be able to align that radio in the vehicle.
Bill, I'd like to throw one more thing in there. I've
Sure.
talked to a few customers that have gotten bit by this as well. They'll have a huge power supply, 50 amp power supply, and they'll have their cable loss compensated for, but they'll be testing their 50 watt radio with like 20 gauge wire. So make sure that not only you have a sufficient power supply, but that the wire is big enough to feed that radio as well.
Right, 10 to 12 gauge for sure. Mike, you want to take one?
Sure. Let's see. I think the next one was asking, I'm sorry, let me see where it is here. Oh, well, somebody's had a batch of new radios, and they ran the auto test, and it immediately called them out for low power, and they found out that they did have a batch of radios that had a bad PAs. The question was about what power level do we use to detect or call it out for low power, and the answer to that is 0.05 watts. If it's below that, then we call it out for low power.
Okay. We've got more questions coming in here. got one question about VNC. I think Dave touched on that. VNC, we do have procedures on how to set that up on the website. I believe it's on the, Dave, isn't it on the 3920 page for
Yeah,
VNC?
well, I don't know if it's made it to the website or not. I did write an app note for that here just a few weeks ago, as well as a set of instructions for doing that. Is that the question from Tyler there that you were
Yes, it
responding
is.
to?
It is.
Okay,
Yes.
yeah. Let me if it's not on the website already, Tyler, we will. I'll make sure we get a copy of that app note sent to you.
We'll keep going here. Here's one from Bernie. He's asking, is there an advantage of doing firmware updates prior to aligning a radio, primarily APX radios? And the answer to that is yes. There are, these auto tests are moving targets, and where the manufacturers are changing their software, and we have to keep up with them. So when it's time to do those preventive maintenance routines, then you definitely want to have the most current auto test version in your service monitor, and that can be found on our website and easily downloaded with the instructions along with them. Mike, you want to take one?
Sure. Let's see.
Mike, while you're looking,
yes, go ahead.
Rodney asked about the test sets realignment and calibration. Viavi recommends a 12-month or 1-year cal interval on our test sets, so the 3920B or 8800SX or 3550R. All of those we recommend a 12-month calibration interval. Of course, we do perform that service at the factory, and of course, doing that gets you a full optimization of that unit, and that's something that I know not everybody is aware of. When you have the local cal van take care of the unit for you, a lot of times, and maybe that's all that matters to you, but a lot of times they'll verify that it meets the specifications. So they go through the calibration, verify it meets the specs, but they don't do any optimization. One of the advantages to sending the units back to the factory for that annual service is that you do get an optimization performed every time it comes through the shop. So if you'd like to, if you need your equipment serviced, please contact our customer service department. They can arrange an RMA for that. Okay, Mike, sorry.
Okay, no, that's good. There's a question of is there a compatibility comparison chart between the 8800SX and the 3920B? And yes, there is. And please just send us an email and we'll be happy to send that to you.
We've got a lot of questions coming in. I had one. Do you have a step-by-step instruction for tuning combiners and duplex cavities for the 8800SX, and then also the 3550R? And the question is yes. As a matter of fact, I'm in the process of doing that right now. We've got a video that was done a few years ago for one of our big customers, and I can get that out to folks that want that, and we are going to have a couple of these going up on the website. One specific to tuning duplexers, so look for those on the website soon. Or you can also email us if you'd like a copy of that. As soon as we get finished with them, I can send you a link to it. So we are having some. We're in the process of making videos right now, so. We'll have updates for the duplexer. There's, like I said, we've got some older ones out there. I think there's some on the site right now, at least an application note on doing that. So the answer is yes, and we've got all of your information out there too, and we're going to go through these questions that don't get answered because there's a lot of them coming in. We will get back with you on email too. So if your question doesn't get answered or answered specifically to your liking, we'll get back with you on email to make sure that you get your questions answered. Mike, you want to take another one? I'll go through a few more of these.
Let's see. One of them is there an advantage to doing firmware update prior to aligning?
Yeah, I answered that one.
The
Go ahead,
radio.
Mike. Give him
Okay,
a
I'm sorry.
synopsis on that too. I know it's I was figuring out a way to check these after we've
Hey, John, if you have a large number of radios, 100 plus to align, my suggestion is to buy another 2 or 3 service monitors. But there are things you can do, I suppose, to reduce the test time. You could, for example, not do the alignment. I think in some cases we have the ability to skip like the low power test if if you are looking only to do the high power multi-band radios. A lot of times, customers may want to just test the band that they use, and they have the ability to do that to deselect the bands that they're not concerned with. So in some cases, yes, there are things we can do to reduce the testing time. Some radios we don't really have that ability, but I guess depends, on in your situation. You're talking APXs. I guess maybe get in touch with me later, and we'll see in your situation what might be done to I guess speed the process through that number of radios.
John Hurley's got a good question here too. Is there a place to find signal standards values for P25 NXD and DMR? There are. The P25 APCO standard does have that information in it, although they're huge manuals. Mike, how do you want to answer that? Because there are places to get those specs, but sometimes you have to dig through these, like the ETSI standard, to find them. Do we have a
Which spec was that, Bill?
Well, it's basically they're asking about P25 and NXD and DMR. So the ETSI standard and the APCO P25 standard, and we know those specs are in there, but you do have to you have to dig through to find them.
Yeah, and really in both cases, like for the digital measurements, the mod fidelity and P25 case and FSKR and the other technologies, 5% is always the maximum. For symbol deviation in all cases is 10%. So that's pretty easy to remember. So in the case of Project 25, where the symbol deviation is 1800 hertz, 10% is going to be 180 hertz tolerance. So it's 10% of the symbol deviation. But those are from the standards.
We've got another question here. Is there any plan to implement the Tetra functions on the 8800 and the 3550? The 8800 does have some limited Tetra functions on it, Victor. The 3920, of course, has got everything on it. We can get back with you on what specifically you can do in Tetra to give you a better explanation of what we can and can't do on the 8800, but it does have the capability of doing some Tetra. I'm going through anybody. Let's see.
Barry, does cable loss affect tuning or measurements? As a matter of fact, cable loss will affect the tuning of your radio, specifically transmit power, and in some cases, it can affect your received bit error rate as well. So, if you have and I'm just going to pick a nice round number, 3 dB. If my 50 watt radio is connected to my service monitor through my cable, it has 3 dB of loss. That means the service monitor is only going to see 25 watts of that. And based on that, we're going to fail that radio, or we're going to try to align it so that we're measuring 50, which means that the radio, we're going to try to align it to 100 watts. So it is important that you use cable loss when you're doing your alignments. That way we make sure we're getting accurate measurements. And again, in some cases, if you have enough cable loss, you actually won't be able to to get there. I had a situation in Costa Rica one time where we were testing a 100-watt radio, and the amount of loss that they had in the cable was causing the service monitor not to read 100 watts. It was well below that, and they tried adjusting it up, and this was manually. So it's not just an auto test thing; it happens manual tests as well. But they had the soft pot maxed out, and we were still well short of 100 watts. And I asked them, hey, what's your cable loss? And of course, everybody kind of scratched their head because it's something that a lot of times I don't think thought about, years ago. Nobody really considered the fact that the cable has loss. I think everybody knows that, but we don't really think about it. When they went through and measured the cable loss, and we were able to put that offset in, we found that the radio was actually putting out about 125 watts with the soft pots all maxed out. So does it affect it? Absolutely, and it's something that that needs to be taken into account when you're doing your alignments. So good question, Barry. Leo, the 3500 does not have VNC capability. The 3500 kind of came about before we really started doing VNC, and as such, and it is the 3500 itself, not the 3550, but the 3500. I guess I would say it's kind of an older test set. I mean, it was. Gosh, it's gonna be almost 20 years old now. So again, kind of before VNC really kind of took off on our test sets. So unfortunately, the 3500 does not have. The 3550 does have VNC capability though, just like the 8800 and 3920. Aaron Slaughter, let us get back to you on that. I think we actually, that's either already in the works or is already out. Let me let one of us check on that and get back to you offline on the 8500, okay? Let's see here. Nick, frequency list in advanced digital. I'm not sure on that. I know that that there are. I think there are some limitations on when we can use that. Advanced digital mode kind of puts the 8800 into a I don't want to say a different mindset, if you will. It reprogram some things internally, and so because of that, there are certain things that we're not able to do. Frequency list might be one of those, and that may or may not be the way it should work. So let us get back to you on that as well.
And we've got a lot of questions out there. We're gonna have to wrap up here in a couple of minutes, but we are gonna make sure that everybody gets their questions answered, because we've got all of this recorded here, and we will certainly get the answers out there too. And I, for one, thank everybody for attending. This is a great response and great questions, and we'll get them all answered for you. Mike and Dave, you want to wrap up?
Yeah, once again, thank you everybody for joining. Like Bill said, if you have if you submitted a question, we'll get that answered. If you think of a question, you're leaving your office now, had to go get some lunch, and you think of something, or you're laying in bed tonight about to drift off to sleep and something pops in your head, please feel free to send us an email. Again, you can contact us, one of us three, directly, or you can contact our sales department and let them know you have a technical question. Either way, that'll get routed to one of us, and all of us are here to help. That's what we live to do, and so if you have those questions, we want to be able to answer them for you. So yes, thanks again. Thank you, Mike and Bill, for your participation and answering some of these questions as well. I appreciate that. Sarah, do you have anything to add before we wrap up?
No, we'll make sure that everybody receives a copy of this webinar, and thank you all for joining us.
All right. Thank you, everybody. Have a good day, good safe day. Thanks.